Yes, Samaira, did you message them?
Yes, I messaged.
अच्छा, you have messaged. अच्छा लास्ट, अच्छा आप लोग का तो क्लास में था. So अब आपको समझ में आ रहा है इक्विलिब्रियम समायरा?
Yes, sir.
अब आ गया आपको. अच्छा ठीक है. And what about you, Hishma? Did you try some questions?
Yes, I did.
अच्छा, you also did. Okay. Samaira, so was there any reply from them, Mariam and Aisha, or?
So they're not online.
They are not online. Okay, fine. Then they must be joining on Saturday. They'll be having class on Saturday. Then. Okay, fine. So in the last lecture, we learned about the plus m and minus m, how to identify what is plus m and how to identify what is minus m. Okay. So what we can do is I can write some groups here that I will attach to benzene ring. Okay, that I will attach to benzene. Boliye.
Mariam has messaged that she will join on Sunday and Saturday.
Saturday and Sunday. Okay.
Yeah.
ये फवाज फिर से आ रहे हैं. फवाज भाई, आपको तो फिर से वही लिंक मिल गया लगता है.
सर उन्होंने 2 भेजी थी ना. ये भी नहीं है.
ये वही लिंक है जो जिससे पहले आपने ज्वाइन किया था.
अच्छा सॉरी.
कोई नहीं. ओके, जस्ट सी ना, कंपेयर कर लीजिएगा एक बार. ज्वाइन करने से पहले सेम लिंक तो नहीं भेज रहे कहीं. ठीक है.
हाँ ठीक है.
ओके ओके. सो mesomeric effect. Okay, so what I can do, I can write some groups. You have to identify whether that will be plus m or minus m. So you remember the rule, right? First of all, you will check whether it is minus m. If the key atom, it is attached to a, if the key atom, first of all, you have to identify the key atom. If it is attached to a more electronegative element via multiple bond, then it is going to be, what? It is going to be minus m. But if the group has lone pair, then it is going to be plus m. Okay, write this down. Let me know if you're done. Acha, Samaira, do you have the date for examination?
So we didn't get the timetable yet.
आपका इंडियन इंटरनेशनल स्कूल है ना?
Yes, sir.
रियाद में 20 फरवरी से है. I think it will be same for you also then.
I guess it will be late, sir, because they didn't finish the portion only till now.
तो कहाँ तक कंप्लीट हुआ है आपका?
Like in chemistry, 3 chapters are left, I guess, 3 or 4.
नहीं, 3-4 chapters are left, but which chapters? अगर आपका S block P block होगा तो वो तो
S block, P block, and thermodynamics.
हाइड्रोकर. अच्छा, थर्मोडायनेमिक्स बड़ा चैप्टर है तो. हाँ, एंड
And I don't know.
इक्विलिब्रियम हो गया.
Equilibrium we started right now. Today only we started.
अच्छा, तो इक्विलिब्रियम भी बचा ही हुआ है. हाँ, तब तो लेकिन फिर भी खींच देंगे स्कूल वाले. एस ब्लॉक में तो बोल देंगे कि ऐसे अच्छा, दे टीच विद पीपीटी.
No, sir. Blackboard mein they write.
अच्छा, इट इज ऑफलाइन नाउ ना. सॉरी.
Yeah.
अच्छा, सो Blackboard thinks it will take time. PPT में ये होता है कि like if you have PPT then you just show them slides, explain a few things, then say that don't write the notes. I will send you the PPT. But I don't know. You have to write what is plus m and minus m. Okay, identify that. ऐसे लिख के मत बैठ जाइएगा. Yes guys, done. किसी में डाउट है तो पूछ लीजिए. If you have doubt in any one of them. Yes, Samira and Hishma, done, or are you having some difficulty? Yes. Okay. Mute. Hello, am I audible?
Yes, sir.
हाँ जी, बताइए, हो गया?
No, sir. So I have doubt in CH2 plus and CH2.
अच्छा, okay, fine. Okay, fine. Tell me for OH.
Plus M,
Yes. NH2.
plus M.
Yeah, because it has lone pair, right? And nitrogen will also have lone pair plus M. What about CHO?
Plus M.
Q. What is the key atom here? Tell me. Key atom is carbon, right?
Yes, sir.
Okay, and I hope you know the structure, no? It is like this: carbon with a double bond oxygen and hydrogen. So we have the key atom carbon. It is connected with a more electronegative element oxygen via multiple bond, right? So minus M, na?
Yes.
What about this COR, C double bond O and R?
Minus.
Minus M. What about carboxylic acid? What about carboxylic acid, guys? Minus M. NO2. NO2. नहीं पता. Minus M, yeah, because nitrogen has a double bond with oxygen. Okay, minus M. Okay, now in this case, you need to be. See, you can see a resonance happening. A double bond B, single bond C, and C has a positive charge. Yes or no?
Yes, sir.
Now, can you see that resonance is like this?
Yes, sir.
So minus M, na, because it is pulling electrons away from the benzene ring, right?
Yes, sir.
Yes or no? Okay. Now this is what? A double bond B, single bond C, and C has a negative charge. So in this case, the resonance will be something like this. Now in this case, what is happening? The electron density, the benzene is pulling the electron density. So CH2 negative, it is donating electron. That is why this will be plus. This will be again minus M. But please listen here, this nitrogen is connected with carbon, which is not electronegative, okay? So you have to say that, first of all, it is not minus M, because nitrogen is not connected to an electronegative element, and nitrogen is the key atom here. You have to look at the key atom. If the key atom is connected to an electronegative element, then only you will say that it is minus M. Now it is a plus M because nitrogen has lone pair. Now this OR, it is also plus M because oxygen has lone pairs. So write this down, let me know if you're done.
Done, sir.
Okay. Now let me show you what happens if we have plus M group and what happens if we have minus M group. So we can write here the plus M effect. Now to showcase this, I will be using OH group. Okay, now in this case, A double bond B, single bond C, and O has a negative charge. O has a lone pair electron. That is why this will shift here. This will go here. And you will write the first resonating structure, something as like this. In the resonating structure, you have to keep in mind that first of all, you are writing everything that is all the single bonds. Okay. Then you will add a pi bond here because electron has shifted here. Then this bond has broken. That is why this will be negative charge. Please remember that this is pi bond is broken. Okay, not the sigma bond. Sigma bond will not break. Pi bond will break. The other bonds are intact as it is. Again, I can see A double bond B, single bond C, and there is a negative charge here. So let me just write these things now, which are taking part. So A double bond B, single bonds. Okay. Similarly here, A double bond B, single bond C, and C has a negative charge. That is why this electron will shift here, and this pi bond will shift on this carbon atom. Then moving on, you'll get another resonating structure. Now in this case, now this, wait a second, one more thing, that oxygen will get a positive charge because it has lost an electron here. Similarly, here you will have OH positive. This bond was as it is. Now here we are forming a bond, and in this place we are getting a negative charge. In this place we are getting a negative charge. Now we can see that A double bond B, single bond C, and C has a negative charge. Now this negative charge is going to move here. This pi bond is going to move in the carbon atom here. Next, we can write that this OH positive is here. We have formed a new bond here. This bond is as just intact, and here we have a negative charge. Now we are going from A double bond B, single bond C, and C has a negative charge. C has a negative charge. Okay. And in this case, what is going to happen? This negative charge is going to form a bond here, and this bond is going to move to oxygen. Now, since we have got to the original structure, that we have OH, and we have a double bond here, we have a double bond here, and we have a double bond here. Now, at this point of time, we can stop the resonance because we have completely delocalized the electrons, and now we can write the resonance hybrid structure. So to write the resonance hybrid structure, first of all, you make the benzene ring, the single bonds, then oxygen and hydrogen. Now, first of all, you will see that all the bonds here, these are partial double bonds, because you can see this is single bond here, double bond here, double bond here, double bond here, and this is single bond here. That is why you will put a dashed line here. And all you can see that this bond is double, single, double, single. All of these bonds are partially double bonds. So we'll write it like this. Now let's look at the charges. So oxygen, it is having delta positive charge because in some of the resonating structure it is having positive charge. That is why it will be delta positive. Now if I look at this position, this is going to be delta negative because it is having some negative charge. This position is going to be delta negative, and this position is going to be delta negative. Now I hope you guys know that the position adjacent to OH, it will be ortho. This is ortho position. This is also ortho position, and this is the para position. Yes or no? Yes or no,
sir.
guys? Okay. So introduction of plus M group increases the electron density at ortho and para position. Write this down. Let me know if you're done.
Done, sir.
What about Hishma?
Done, sir.
Okay. Next thing you can write. So we have plus M group, right? Plus M group. Okay. Now, see, if we have a plus M group and there is, okay, we will talk about the intermediates later. Okay, talk about the intermediates later. Let's first of all write the minus M group. Right, the minus M effect. So for this, we will be using NO2 group, nitrogen, double bond oxygen, the dative bond, oxygen here. These are the rings. So first of all, this oxygen will take electrons, and it is going to form single bond nitrogen, single bond oxygen, single bond oxygen, oxygen, and there will be a positive charge here. Now, in this case, the electron will be moving from here to here, making a double bond nitrogen, oxygen, and oxygen. This will be getting a positive charge. Here will be double bond. Here there will be a double bond. This double bond will move that side because electron source to electron sink. Then this will be again nitrogen, oxygen, and oxygen. We'll get a we'll get a pi bond here. The pi bond here is intact as it is. Yes, sir. Carbocation here. This pi bond will move electron source to electron sink. This is going to form a pi bond here. This pi bond is intact as it is. This double bond nitrogen, oxygen and oxygen. There will be a positive charge here. Now this, okay, I forgot these negative charges. So let me write those negative charges. What is going to happen? This oxygen is to add electron here. This pi bond is moving here. And you are going to get back the NO2 group as it is. So you'll have a pi bond here, a pi bond here, and a pi bond here, and you will have the NO2 group like this. So the pi bond O, oxygen with a dative bond like this. Okay. Now, if I want to draw the resonance hybrid structure, it will be something like this. That NO2 is there. Okay, sorry. Wait a second. Yeah, sorry. Okay. So this will be double bond, partial double bond. This will be partial double bond. And we can say that we will have a delta positive in the ortho and para position, right? So I can write introduction of minus M group decreases the electron density at ortho and para position. Ortho and para position benzene. Okay, ortho and para positions of benzene. Write this down, let me know if you're done.
Done, sir.
Okay. Now we know these two things that you can summarize. That if you have benzene, then first of all, both of these things, that plus M and minus M. So if you have mesomeric effect, then it is going to affect ortho and para position, right? Ortho and para positions. It is not affecting the meta position. Okay. Now, if you have two types of mesomeric effect, if there is plus M, then it is increasing the electron density at ortho and para. If you have minus M, then it is decreasing the electron density only at ortho and para, not at meta. Okay. So mesomeric effect does not affect the meta position of benzene ring. Write this down, let me know if you're done.
Done, sir.
Okay. Now let us look how it is going to affect on the stability of different groups. Okay, stability of different carbons. Compare the stability. So in this you have CH2 positive. Okay, this is just a CH2 positive. Secondly, you have CH2 positive, but this also has a OH group attached to it. Okay. Secondly, you have the same CH2 positive, but there is a NO2 group attached here. Okay, let me write D. You have CH2 positive, and here you have OH group attached. Okay, OH group attached. So first of all, what you are going to do, you are going to write what is the effect. Okay, what is the effect, and at which position the substituent is. So in this position, there is no substituent. That is why you will just write dash here. In OH, you will write that it is on the ortho position. It is on the ortho position. Next, you will write that NO2, it is also on the ortho position. Okay, ortho. This is ortho. Okay, this is ortho. And here the OH is in the meta position. Okay, any doubt till here?
No, sir.
No doubt. Okay, fine. Now, what is the effect of OH? If it is in ortho, then it is plus M. Yes or no?
Yes, sir.
Now, what about NO2? It is minus M. Yes or no? NO2 is minus M now if it is in ortho position. Hello? Yes or no?
Yes.
Okay. Now, what about OH? If it is in meta position, it has no effect in meta position. Yes or no?
Yes, sir.
Okay. Now, this is you have looked at the mesomeric effect. You have to now compare. You have to now compare about the C. If I talk about B and C, then we can completely say that B will be more stable, right? B is the most stable one. But I have to now compare minus M. So this will be the least, right? B, and we will have the least stable, which is the C, because we have a positive charge and NO2 is pulling electron. NO2 is pulling electron. So what OH is doing? OH is in this carbon atom, it is introducing a delta negative charge. And here the NO2 is introducing a delta positive charge. So positive will repel each other, and it cannot. I mean, this delta positive, it will be pulling electrons. Here delta negative is there. It will be giving electrons to the CH2 positive. And hence we can say that this OH is what it is. It is stabilizing the CH2 positive. It is stabilizing the carbocation. But we have to compare. We have to compare this minus M. I can obviously say that C will be the least. Okay, at last we will have the C. But what about A and D? What about A and D, which is going to be more stable, A and D? Now, in this case, you have to compare the inductive effect. I can say that O oxygen, which is a minus I effect, it has a minus I effect. And here we don't have any effect, right? Now, this minus I effect is what? It is destabilizing, right? It is destabilizing. That is why it will be just before C, and then we will have A here. Do you understand this? Yes or no? Tell me. How to look at the stability? Achha, but first of all, if we have carbocation, that means the electron releasing group is going to stabilize. That means plus group are going to stabilize, and the minus group are going to destabilize. Yes or no? What happened, guys? Yes or no? Am I not audible?
Yes, sir, you are audible.
ये नहीं आया आप लोगों का? You did not
No,
get this?
sir. No,
Okay,
sir.
fine. नहीं, अच्छा, fine, no problem. I actually skipped a few things. Okay, fine, no problem. But you can talk about. If I will just talk about minus and this two you understood, or yes or no? Tell me. For B and C.
Yes, I understood.
For B and C understood, but not about DNA. How to compare DNA? है ना?
Yeah.
Okay, fine, no problem. DNA we will compare at last when we have learned all the electronic displacement of it. Okay, all the electronic displacement of it. Okay, as of now, what you can do, you can write the order of plus M and order of minus M. We have seen a lot of plus M group, so the order of plus M groups. So first of all, obviously you will have some positively, plus M negatively charged. That means you will start with CH2 negative, highest, which will be followed by NH negative, which will be followed by O negative. Okay. Now after O negative, you will have NH2, which has electron as lone pairs, followed by, if you can have NH, which is bonded with R, you can also have N, R2, N R2. This will be followed by OH group, followed by OR group. This will be followed by NH, C double bond O, R group. Okay. This will be followed by oxygen, which is having a carbon double bond oxygen, and here you are having an R group. Then write the order of minus M. First of all, you will be having the positively charged, that is CH2 positive, followed by NO2, followed by CN, carboxylic acid, the ketonic group, the aldehyde group,
Done, sir.
Then all of you. Okay. Right, next about hyperconjugation. Hyperconjugation. It is also known as no bond resonance. Also known as no bond resonance. Okay. Now, how does hyperconjugation take place? Please write the delocalization of sigma, that is CH bond. The electrons of CH bond electrons, the delocalization of CH bond with pi bond or positive charge or free radical is called hyperconjugation. Hyperconjugation. Okay, so we can either have pi bond, a positive charge, or a free radical. Okay, and there should be a CH bond on conjugation with it. Okay, that means it should be near that. It should be near that. So we have what the condition is that pi bond, positive charge, and free radical. Okay, so let us see if I have CH2 double bond CH2, and if I have CH3 positive, and if I have CH3 free radical. What is common in all of these is that whenever you will have a pi bond, the carbons, they will be sp2 hybridized. This is also going to be sp2 hybridized because there are only 3 bonds, and this is also going to be sp2 hybridized. Okay, and essentially what we are saying is that there should be an sp2 hybridized carbon atom, and there should be some CH3 group attached here, right? So we will have some sigma CH bond. Then we will be having hyperconjugation. Okay, so you can write this thing, that the common thing between all of these pi bond positive charge and free radical is that all of these are what? sp2 hybridized. All of these are sp2 hybridized. So write this, then you will write about the conditions.
Done, sir.
Done? Okay. No. Conditions for hyperconjugation. First condition is that there should be at least one sp2 hybridized carbon atom. Okay, one sp2 hybridized carbon atom. This will be only possible if you have alkene. Okay, this is only possible in alkene. If you have any alkyl carbocation, or you have any alkyne free radical. Okay, any alkyl free radical. Second condition is that alpha carbon with respect to the sp2 hybridized, carbon, the alpha carbon with respect to the sp2 hybridized carbon, it should have at least one CH bond. It should have at least one CH bond. So these are the only two conditions. You guys know alpha carbon, yes or no? No. Okay, fine. I think हमने बताया alpha carbon, ऐसा क्यों लग रहा है हमने बताया alpha carbon? I have not. I don't know. Done, guys? Samaira, Hishma?
Yes, sir.
Okay. So see, it's very easy, very easy. First of all, I will give you some examples in which you have to identify the sp2 hybridized carbon atom. Okay. So I'm giving you some structures. A, B, C, and D. Okay. Write this down. Let me know if you're done. Then we can identify the sp2 hybridized carbon atom.
Done, sir.
Done. Okay, fine. So in the A structure, you can see that this carbon is sp2. These two carbons, yes or no? Yes or no, guys?
Yes, sir.
Anna, what about B? Which carbon is sp2? 1, 2, or 3?
Second one.
Second carbon. What about C? 1, 2, or 3? Which carbon?
Third one.
Third one. And here, this is the carbon which is sp2 hybridized. Okay, fine. So you can identify the sp2 hybridized carbon atom. Now, alpha carbon means adjacent carbon. Alpha carbon means what? Adjacent carbon. Okay. So if I talk about the alpha carbon, then this will be the alpha carbon, yes or no? Guys, this will be alpha carbon adjacent to sp2. Alpha carbon means carbon with carbon adjacent to a particular group. Okay, here sp2 carbon. Okay, yes or no? Can you identify now alpha carbon? है कि नहीं बताइए?
Yes, sir.
Yes,
This
sir.
will be alpha carbon. Yes or no? Fine.
Yes, sir.
अच्छा CS3 होगा यहाँ पे. Sorry, my bad. CS3. Okay. What about in this particular case? This carbon can also be alpha. This carbon can also be alpha. Yes or no? The CS3 and the CS3. So both of these are alpha carbon. What about this case? Only this carbon is going to be alpha carbon. Correct?
Yes, sir.
Now in this case, these two are going to be alpha carbon. Yes or no?
Yes, sir.
Okay, fine. Now all of you, now you can identify the alpha carbons and you can identify the sp2 hybridized. Now let us look how a particular hyperconjugation it take place. How hyperconjugation take place? We have carbon. This carbon has 3 hydrogens. Okay, and it is attached with a carbon atom which has 2 hydrogens and a positive charge. Okay, the positive charge means that one p orbital will be vacant. Yes or no? Because it is sp2, carbon has 3 p orbitals, so one of the p orbitals will be empty, and that is why it is having a positive charge, right? It is having a positive charge. Correct? Now as you know, when we have a positive charge and there are electrons here, right? There are electrons here. Now what will happen? This particular hydrogen, it will shift here for time, for a very little time. It will shift there and it is going to form C double bond C. There will be hydrogen here like this, hydrogen here like this. This hydrogen that we have removed will form H plus. And that is why, as you can see, that there is a no bond. Right? There is no bond between C and H. That is why it is known as no bond resonance. This is also known as no bond resonance. Okay. Now this is going to be happening always. Okay, this is going to be happening always. This carbon atom, it will be forming a double bond. It is going to form. Then it is going to form a C double bond C. C double bond C. Okay, if you have a particular, if you have a sp2 hybridized carbon atom and then there is a CH bond near to it. There is a CH bond near to it. Okay. Now, in this case, as you can see, that there are 3 hydrogens, right? There are 3 hydrogens. So all of these hydrogens can take part in hybridization. Okay. All of these hydrogens can take part in hybridization. What can happen? In some moments, this hydrogen, the black hydrogen, is going to give the electrons. Some moment this electron, this is going to give the electrons. Some moments this is going to give the electrons. Now I can say that there are 3 alpha hydrogens. 3 alpha hydrogens, hence 3 hyperconjugating structures can be formed. Okay, 3 hyperconjugating structures can be formed, and those 3 structures will be something like this: carbon double bond, carbon, H2. So sometimes H plus, and these will be having bond with hydrogen, bonded with carbon. Sometimes carbon will have bond with hydrogen here like this. This will be C double bond H2, and this hydrogen will be giving the electrons, and this will be having bond with hydrogen like this. And sometimes what will happen? This carbon and hydrogen will form bond, and the hydrogen which was here, it will be giving up its electron to form the pi bond with the adjacent carbon atom. Okay, so these are what these are the hyperconjugating structures. Okay, write this down. Let me know if you're done.
Done, sir.
All of you.
Yes, sir.
So see, next is if we have the stability now, stability is directly proportional to the number of hyperconjugating structures. And we know that number of hyperconjugating structures is directly proportional to number of alpha hydrogens. If we have more alpha hydrogens, if we had 3 alpha hydrogens, that means 3 hyperconjugating structures. If we have 6 alpha hydrogens, then there will be 6 hyperconjugating structures. So number of hyperconjugating structures is directly proportional to the number of alpha hydrogens. Hence, I can say stability is directly proportional to the number of alpha hydrogens. Okay, number of alpha hydrogens. Also note here, stability of alkenes is given by, that means it is calculated, it is approximated by hyperconjugation. Okay, for alkenes. For if you have any free radical or carbocation, it will be also affected by plus M and minus M, but alkene, it is solely judged on the hyperconjugation. Okay, so please write this down. Let me know if you're done.
Done, sir.
Okay. Okay, determine the number of alpha hydrogen in following. Yes, you have written the question, yes or no? Ishma and Samaira?
Yes, sir.
Okay, so first of all, you will identify the sp2, hai na? So you tell me, in this, the CH2, this is sp2 hybridized, yes or no?
Yes, sir.
This carbon atom is alpha carbon.
Yes, sir.
So how many alpha hydrogens?
3 alpha.
So, okay, fine. Alpha hydrogen, it is equal to 3. What about here? In this case, this is sp2.
Yes, sir.
This is also alpha, this is also alpha.
Yes, sir.
Now, number of alpha hydrogen is equal to how much?
6.
6.
Okay, very good. In this case, alpha hydrogen is equal to how much?
6.
9, na? This is also
Yeah.
alpha. This is also alpha, right? Yes, Hishma, 9, na? Okay, what about here in D structure? How many alpha carbons? First of all, tell me that. How many alpha carbons? Hishma and Samaira. What happened? This is the sp2.
Yes, sir.
So how many alpha carbons? So this is also alpha carbon. This is also alpha carbon. Yes or no?
Yes.
Yes.
Sir.
Now, how many hydrogens both of them are having? They have how many hydrogens with them? जी समायरा बताइए आप यहाँ कितने हाइड्रोजन होंगे?
3.
3. ये आप लोग तो कुछ नहीं याद करके रखे हैं. 3. Do you
2.
not remember? 2. है ना? What is the formula? 4 minus bonds. It is equal to number of hydrogens. है ना? Yes or no? You have
Yes.
done this, right? So it has to. This will be having. So here you have alpha hydrogen. Here also you have alpha hydrogen, and both of these are having. If I add them, this will be equal to 4 alpha hydrogens. What about E structure? So this is also sp2. This is also sp2, right? And this is alpha, and this is alpha.